We barely think about gravity in our daily lives, but we must realize that it defines how we interact with the world. We grow within its constraints, and our heart, our muscles, and our balance system depend on it. Gravity is one of the fundamental forces of the universe. In this video, let us understand what gravity is and how it affects us. We'll briefly go through what is gravity, the history of gravity, gravity in the universe, how to measure gravity, gravity in the earth, and some examples of gravity. So let's begin. What is gravity? Every object that has mass exerts a gravitational pull or force on every other mass. The strength of this pull depends on the masses of objects in play. Gravity keeps the planets in orbit around the sun and the moon around the earth. Hence, we define gravity as a force that attracts a body towards the center of the earth or any other physical body having mass. This simply means that because of gravity, anything at all that has mass is attracted to any other thing that has mass. The history of gravity. In 1687, Sir Isaac Newton first discovered gravity. While sitting under an apple tree, he noticed an apple falling down. Then he tried to figure out why the apple came down instead of going up or going left or right. In this situation, there was clearly an unknown force at play. That force is what Newton called gravity, and his theory is called Newton's law of universal gravitation. Let's talk about gravity in the universe. So after understanding what gravity is, let us know how gravity plays a major role in sustaining life on planet Earth. Because of the gravitational pull between the Earth and the Sun, the atmosphere is kept in place and provides us with the air we need to breathe, to survive, very essential. And also because of gravity, the atmosphere stays in place and keeps us safe from the sun's intense radiations, allowing us to enjoy the sun's light and warmth. How to measure gravity? Sir Isaac Newton defined the force of gravity as follows. Every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of the masses of the particles and inversely proportional to the square of the distance between them. You can replace as many times as possible to understand it. But mathematically, this translates into F is equal to G multiplied by M1 multiplied by M2 all over R squared, where F is the force, M1 and M2 are the masses of the objects that are interacting, and R is the distance between the center of the masses, while capital G is the gravitational constant, and it's given as 6.67 10 to the power minus 11 newtons. This equation gives the magnitude of the force, and since it is an attractive force, it will always be directed towards the other object. So in our past videos, we talked about magnitude and direction, and anything that has magnitude and also has direction, you know it. Is it scalar quantity or vector quantity? You know the answer, and I'll keep it for you. From the above equation, we can come to the conclusion that anything that has mass has gravity. Objects with heavier mass have more gravity. The closer the two objects are together, the heavier the gravitational force between them. Gravity gets weaker with distance. Now, the above formula is used to calculate the gravitational force between two objects. Now, let's talk about gravity in the Earth. Gravitational force is the force that builds an attraction between two or more bodies. The objects with less mass have a weak gravitational pull, while the objects with larger mass have a stronger gravitational pull. Objects are held down to the ground because of the gravitational force of the Earth. Objects actually exert a force of gravity on the Earth. Now, because since every object on the Earth has very less mass than the big Earth, the gravitational force exerted by such objects is negligible compared to the Earth's gravitational pull. The average gravitational force of the Earth is said to be 9.8 meters per second squared. Now let's see some examples of gravity. After knowing what gravity is, let us have a look at some few examples of how gravity works. Gravity is responsible for water resting at the bottom of a glass instead of hovering over the top. Gravity causes the moon to revolve around the Earth. Gravity causes the planets to revolve around the sun. Gravity keeps satellites around our Earth. Like we've already discussed, gravity holds the atmosphere in place around the Earth, protecting us from the intense rays of the sun with the help of the ozone layer and the atmosphere. Gravity keeps us alive, enjoying the sun and the moon and the atmosphere. If this content was somewhat helpful and educational to you, then like and subscribe. And that might make me see you in the next video.